in the previous discussions, we had a value of pi. So pi is something that we took from constants, and indeed we can have our own constants such as pi defined in our program. So how do we do it? Well, let me show you. Essentially, in Rust, what you can have is you can have global variables. Now, the variable that we have here, like the variable a, is only available within the function, whereas the variable that I put here outside the function that we were in is going to be available just about everywhere, and it's going to live for the entire duration of the program. So while the program is running, this variable is available. And if you want a global variable, if you want a global variable with a fixed value, there is actually two ways of doing it. And one of those is to have a constant. So let's have a constant. The way you make it is you specify the const keyword, then you give it a name, like meaning of life, for example. You have to give it a type. You absolutely have to give it a type, like U8, and you give it the initial value of 42, for example. So in this example, we've declared a variable called meaning of life, and there is a bit of an issue here, which you have to bear in mind. It's rather technical. This variable that we supposedly have declared, it has no fixed address, because what happens is whenever you use meaning of life anywhere in your program, like for example, let's suppose that you simply decide to print it here. So I decide to print line meaning of life just like this, meaning of life. What will happen at compilation is the value of this variable, in this case 42, is going to replace what I just wrote here. So it's going to be as if I wrote 42 here. Instead, I just wrote meaning of life. Obviously, the output in this case is fairly obvious. So this is one of the ways that you can actually work with kind of global variables which are not going to change their value, and it's very convenient. However, there might be situations where you might want to actually take the memory address of a variable. So you want a variable which is available to the entire program. In this case, there is yet another option to declare a static variable. So you do that by using the keyword static. You give it a name, once again, all capitals, and you can give it a type and also a value like 123. And once again, in this case, you can just go ahead and, sorry, this should have been a Shift Z in here. So like this, let's run this and let's see the actual value. So static is another way of having a global value, and it gets a bit more interesting if you decide to have, for example, a global value which is also mutable, because it is also possible. You can put an MUT in here. However, what would happen as you try to kind of run your program is you're going to get a bit of an error, because you see, if a variable does not have an address, if it's just inlined everywhere, which means the value just gets copied to each location where you use it, then memory safety is not compromised. However, if you have a mutable variable which is accessible to the entire program for its entire duration, what can happen is separate threads might be reading and writing to this variable, and this is an unsafe operation. And this is a bit of a problem, and this is something that Rust tries to fight against. So one of the possibilities for using this variable, if you really must use a global static variable, is to declare this block as unsafe. So an unsafe block is essentially your promise that you're working carefully with this variable and you're not screwing things up. In this case, it's going to compile and is going to work just fine, and in fact you can assign it a different value, for example 777. That's also going to be working just fine. However, in most cases, if you just need a constant like pi, for example, it is much better to use const than to use static.